1 in 5 adults worldwide don't know how to read. In areas like West Africa, it's as many as 80% of women over 15 don't know how to read, roughly 70% of men.
Reading is such a fundamental asset for anyone. If you know how to read, you can vote and know who you're voting for. If you know how to read, you can know the right dose of medication to give to your sick child.
When we talk to organizations that work in this field of adult literacy, their two biggest obstacles to reaching students and teaching people how to read are books and lighting. We're talking about, again, rural communities very far from any urban center. Most of them don't have electricity. They're nighttime literacy courses because all of the adults have to work during the day. There are these huge populations that have great needs, and at the same time, we have 500,000 engineering students in the United States, something like that, who are looking for interesting projects to work on.
Design engineering has very practical considerations as well as the human considerations. And Design That Matters brings all of that together in an exercise of learning.
Design That Matters works to improve the quality of life in underserved communities. That's the basic mission. We do that through product development, in essence.
We package those problems as curriculum materials for students and faculty to use in engineering and business courses.
Yeah, one of the reasons I took Design That Matters was the idea of using your engineering skills to help the developing world. And one of the design challenges was coming up with some kind of low-cost system of putting books on a very cheap medium that wasn't computers.
The idea was to develop a proof of concept that you can use microfilm and an LED to project information.
You fit it in the palm of your hand, and it's very cheap. You don't need much power to read microfilm.
You run it on a car battery or even a pedal generator or something like that.
Then you get to the state of a prototype. So, okay, now we know that the concept works. Can we put it in a package that's inexpensive, is appropriate for the setting, etc.?
We decided as a team was really we wanted to take this product to a stage where it would really benefit people.
So with the alpha prototype, we have maybe 6 different sub-teams, and it's hard to interface all those components into a working product.
With a program like SolidWorks, I was able to work with a team of people, and really the housing and internal components could be developed at the same time.
And we could actually take the product and explode it into all of its individual components, and then put all the components back together. And in that respect, it helped actually us and the public in seeing how these products interface.
You can change the dimensions to adjust for things like human interaction. How easy is it for them to notice these buttons? How easy is it for them to manipulate them?
What was one of the awesome things about SolidWorks is it allowed us to machine directly from the drawings. We'd actually use these same files and translate them into a file that the water jet machine could cut in a matter of minutes. So we built this prototype in 2009, and then with Design That Matters, we were able to bring this product to Africa and actually try it out.
We took the device to Mali and Benin over 6 weeks this summer, where we were testing it with 10 or 12 different communities, schools, non-governmental organizations to really get community feedback.
We actually brought the Kinkajou to a classroom, and the teachers taught nighttime literacy courses to the students for about a couple hours that evening, and it was incredible.
And here they are trying to go to school and learn how to read and advance themselves as much as they can. So it was exciting for them, and it was also exciting for us. Being able to see people in Mali really look at your product and say, hey, I know how this works. When I turn this button on, I know how to make this product work.
The teacher said that it was that using the Kinkajou for many of the students was sort of like watching a movie. Just an awesome experience for them because most of them had never been to a movie.
Where we are now is that there are 18 student teams who are continuing the development of this design. Students build on each other's work, and eventually after hopefully less than 3 to 5 iterations, we wind up with a product that we can then send to the community and change people's lives.
Hopefully at that point, enough of the risk has been taken out of the project that one of our partners is willing to move forward on producing it and distributing it.
By working on these kinds of projects, we're giving students opportunities to realize their capacity to create change.
It made it feel like all the energy that we put into designing this product was actually worth something.
Really working on a project like this to get to see how those things can come together and actually make a difference.
It really means that there's going to be more responsible people with kind of a much wider perspective on what the importance of engineering is.
A generation of designers who are thinking about serving the needs of other people, serving the needs of humanity, and serving their own personal needs in terms of what they want to do with their lives and their careers.
I'm hoping that after grad school I can work on similar projects like the Kinkajou to make real products for people.
That is one of the most important contributions that we can make. Creating this cadre of alumni who are committed and enthusiastic to creating change throughout the rest of their career.